I was going to say, last time I gave a talk with a clicker, I threw it. So you people in the front might want to back up. That's what happens when you're a hand talker, I guess. So I want to get a sense of my audience first. How many of you get excited about detection probabilities? And how many of you are maybe uncomfortable or skeptical or scared of models? A little bit? Okay, less than I was expecting. That's good. And how many of you have actually been out in the field and conducted a point count survey? Okay, you're one up on me. I just analyzed the data. So, you've gotten quite the introduction to my presentation because much of Kari's talk led up to what I'm doing here. But basically, I will give a little bit more context. I'll talk about the Boreal Avian Modeling Project. Modeling, not monitoring. Big distinction there. And I'll tell you what BAM is all about, what we do, why we were approached to work on this project. I will focus probably quite a bit on the approach I'm taking and the intended outcomes. I have some very early results, just a small little glimpse at what's going to be coming. And then, assuming I don't ramble on too much and there's time, I will talk about next steps, both in the immediate few months and year, and then hopefully long term. So as Kari told us about the stand ranking matrix, the idea being each forest stand type is assigned, or each forest stand is assigned a rank from 1 to 6 based on a combination of these 4 forest attributes pulled from the VRI dataset. And Kari did not produce a full map, so I have done so here. And the gray areas are the ones that are in the VRI dataset but not ranked. And the lighter yellow colors are lower rank, suggesting lower bird density, or at least that's the assumption we're making. And then the higher ranks are the red ones. And again, like Kari said, the matrix is a best guess, and there's definitely a recognition of the need for testing. So enter BAM, Boreal Avian Modeling Project, where you can go on our website and we've got a list of 8 very complicated objectives, but very quickly we collect point count data that mostly other people have collected, and we put it in one massive database that's standardized. And we develop and apply statistical methods, models, to analyze these data in conjunction with biophysical or habitat variables as well. And we answer questions about bird ecology, try to understand habitat needs. And then all of this is meant to be applied. So how do we inform bird management and conservation using the models and the results that we can produce? And this is most of the BAM team. That photo was taken just yesterday, so very recent. This is the BAM data set. On the left, we have non-breeding bird survey data, and on the right, we have breeding bird survey data. They're pulled apart because if you put them in the same map, you can't see anything. I will say, though, that the black on the left, that does include the atlas. So breeding bird atlas is included, and you'll see on, I think, my next slide, that not only is it included, but it contributes a great deal to the data set. So you can get numbers of what we're talking about across the country. This is to remind me to thank everyone for submitting their data, including individuals and institutions. Without these contributions, the BAM dataset wouldn't exist, or at least it'd be much, much smaller and probably localized in Alberta. Thanks, Erin. So this is where we zoom in on the BC data. And so one of the first things that I had to do with BAM was improve our data set for BC. So in August, when I started working on this, we had data from only 12,000 or 12,500 stations across BC, including the purple is our older BAM database, plus the red ones is the BBS data. Over the last 6 months, Trish Fontaine, our database person, has gone out and solicited and also acquired publicly available data to augment our previous data set. And now we're looking at this coverage. And as I said, without the atlas, with the atlas. Now we're looking at about 36,000 stations across the province. My legend is wrong. I noticed this just now over lunch, but so the turquoisey color is actually the stands that have been sampled. And I know that you're probably thinking, Nicole, there's something wrong here because look at this coverage. Well, I'm talking about individual stands in the VRI data set. Those polygons are tiny compared to the provincial scale. So if we actually summarize that up to the forest stand types, so if you remember that the matrix is, it's a combination of 4 different attributes. If you do a factorial combination of that, you get something like 3,300 different unique combinations of potential combinations of those attributes, potential forest types. A lot of those don't actually exist. There's only about 1,400 of them received ranks. And so what I did here was summarize and map at the forest type level. So how many, the color indicates the number of point count surveys that were conducted in any stand of that forest type. So even if that type was somewhat far removed from some other type. So as long as a forest type received at least one sample, it is light orange or yellow or green. And the red is indicating where there's been no sampling. So that's what we're talking about in terms of coverage. How do I combine? How does BAM, who I'm just the single representative of right now, BAM combines point count data that, as so many of you volunteered that you have done point count surveys, I know you know that there's incredible variety in how they're conducted, sampling radius, duration. I know you know that there's differences in detecting species. And what Peter Solomos, our statistician, has done is created a method that allows us, he calculates statistical offsets based on the methods, on removal sampling methods and distant sampling methods, and then also species characteristics to calculate or to adjust the count to a density estimate value. And so when I'm building models, I'm actually trying to estimate detectability corrected density. I'll skip over this because I think I'm rambling and this just repeats what you already know. We want to test the matrix using data. That's what I'm doing. The other thing I'm doing is testing the ecological assumptions underlying the matrix. So not just simply do the ranks indicate density, but also all of the list of assumptions that Kari showed us about shapes of relationship between forest attributes or forest structure and bird density. And then the last piece is also identify where more bird data are needed. Also, as Kari mentioned, it's envisioned as an iterative process, and I can identify locations where more data are needed to improve my models, to improve that sampling coverage. They can go out and get more data, they being people that are not BAM, can get more data and contribute it back to the data set. Models can improve, and it can just be this continuing improvement of the process. So I did not coordinate this with Kari, but I also pulled out some of the assumptions that are theoretically possible for me to test. I have an animation here. There we go. So I did not test whether nest density is positively correlated to bird abundance. I was appreciated that Kevin had that statement in his presentation because that assumption, I'm just taking that as a given. I don't have nest data. The one that I'm focusing my talk on today, the one that I've spent most of my attention on, is this really basic underlying the ranks indicate bird nest density, but that's built on the assumption that nest density is indicated by bird abundance. So basically what I'm doing is trying to assess whether the ranks can be used as an index of bird density. The other assumptions that I'm not testing, but theoretically can and will be doing in the future, are about relationships between bird abundance and stand age, relationships, the interactions of bird abundance and forest attributes, depending on the leading tree species, et cetera. And then for example, that certain tree species are functionally the same to birds, which is the premise on which certain species groups were combined. I'm going to get into the results, and I have a disclaimer here. They are preliminary results, and I'm happy to talk to people about what we've got and whether you see any problems with them, but basically take it with a grain of salt. The question that I addressed with these analyses is, do ranks indicate bird density? Simplest case, we see a positive correlation. The ranks were not developed to be linear. There's no quantitative value associated with the ranks, and a 1 doesn't indicate a certain density of nests, and a 6 is not meant to indicate another density of nests. But in the simplest case, like I've depicted here, there is going to be a relationship between stand rank and bird density. That's not realistic. The more realistic case is that we're going to see that relationship between, assuming that there is a relationship, the relationship between stand rank and bird density will vary by Beck zone. And even more realistic than that is that the relationship is going to vary by the combination of Beck zone and leading tree species. Because you just see variation depending on site, productivity, and tree species diversity, tree species structure. So the simplest case was I did do the correlation for this. It's correlation of very low. It's not negative, it's positive, but I think it's like 0.0 something. So the simplest case didn't follow through with the data. The total bird density per hectares does not reflect rank. So rank on its own doesn't tell us about bird density. But like I said, that's the simplest case. That's what we want it to look like if it's a perfect correlation. It doesn't look like that. But the more realistic case was, let's split that out by Beck zone. And so I've only pulled out a couple of examples because it starts getting very large number of graphs the more I split it. But here's one where it looks like maybe there's a relationship. Again, I do have the numbers testing this, but I wanted to focus on the big picture for now, and I can't remember the number off the top of my head. But so rank here on the x-axis, total bird density on the y-axis. Yeah, it looks like maybe there's a bit of a relationship with some variation where total bird density is indicated by rank for Engelmann spruce and subalpine fir Beck zone. In another Beck zone, that does not hold true. And I don't know, that 6 worries me a little bit. But, I mean, it may be that there's only a couple of stands that are ranked as 6, and so the variation is just obscuring the picture we're seeing here. I know I need to dig into this more, like I said, preliminary results. So, but again, remember I said that this is the more realistic case, but not the even more realistic case. So let's split it out by Beck zone and tree species. And that's what I've done here. I've only pulled out 8 different of the 21 different theoretically possible species, the tree species groups. This is for that interior Douglas fir Beck zone. And what we want to see in the ideal case is that for all of these, from left to right, we're seeing an increase because the x-axis is still rank, the y-axis is still bird density, and we want to see, yeah, there's a positive relationship. Rank is telling us about density. For some of these tree species, for some of these stand types, that seems to be true, and for others, it's not true. And I don't know why yet. I need to dig into that. An alternative to the matrix approach would be something like a habitat model. So I create a map of predicted density based on models that are built to describe the relationship, to describe and quantify the relationship between observed bird numbers, and the underlying forest characteristics. Those forest characteristics can be described by the VRI attributes, or I can also throw in other things like climate. I asked whether you're scared of the word model, and this is the slide I used to talk about modeling to make people feel a little bit more relaxed about it. I don't think I need that for this crowd, but basically models are simplified representations of things. And we go, not we, other people that have submitted their data to BAM go out and do a bird point count. And we have intersected those point count locations with the VRI data to extract out those forest attributes. We relate those forest attributes to the bird point count data using various modeling approaches, have the model, and then predict it out. This is not actually prediction, this was an example I created for demonstration purposes. But the idea being that we know we only have sampling for, I didn't say this earlier, but we only have sampling for half of the 1,400 unique forest stand types right now. That's why I'm going to have these recommendations for where more sampling should be done. And the results I presented earlier were also only calculated based on those forest stand types that have bird data in them right now. So the model allows me to create a tool based on relationships, and so that I can interpolate and basically predict out how many birds we would expect to see in different stand types, even if we don't have any point data for those. The idea being that we create a map of predicted bird density for the province, total bird density. So that's what this looks like. Based on a preliminary boosted regression tree model that I ran last week. And I'm going to put it next to the rank map. And I noticed that the color scheme is not consistent, which is going to obscure your visual comparison of the two. This is what happens when you leave things to the last minute. Don't do that. But on the left, we have rank, where darker colors in general indicate higher ranks, and therefore what we're assuming is higher bird density. And on the right, we have the modeled predictions of bird density, and darker colors indicate higher density. I have not overlaid these yet to do any sort of correlation, so that's still yet to come. But what one could do with a map like this is, instead of the matrix-based GIS layer, one takes this GIS layer and uses that in one's planning process. We've encountered a number of challenges. Kari knows this all too well, as I keep pushing back my delivery date. First challenge was data inconsistencies. First of all, massive data set, which I'm sure any of you know if you've used VRI. Also, the bird point count data, also massive. So that was the first challenge. Second has been data inconsistencies. The matrix process has evolved over time. Species groups were defined and redefined, and some of the names changed and the documentation changed. And I'm not a forester, so it took me a little while to get into understanding, this species group actually is the same thing as that other one, and get that standardized. But I've been working with Kari's group to do that. One of the early questions came up was, do we model total bird abundance or total bird density or individual species? I'm used to modeling at the species level. That's where I feel most comfortable. But this is about total bird density, so I had to make that adjustment. And more than just me, but Peter Solomos, our statistician, needed to create an offset for total birds rather than individual species, which is where he's got the offsets. The tool that allows us to standardize the point counts is now available for the total bird models. Like I mentioned, the representation of the data, the forest stand types, right now only about half of the unique ranked forest stand types have bird data in them. So that's a challenge for modeling. When you're talking about extrapolating into unobserved forest types, how much do we trust that? And then temporal alignment, which we thought was actually going to be a bigger problem than it probably will. But basically, when you make a database by combining together historic data, you end up with point counts back to 1994 or earlier. And the VRI data set that I'm using and that these ranks were based on, or like the spatial version of the ranks, is 2014. So if anything has happened to that forest stand, say for example, aging, then, or harvest or fire, then the characteristics that were associated with the actual observed number of birds that are in my data set are not going to be reflecting what's in my VRI data. So my models are going to be probably not biased, but they're going to be noisy, and I may not be able to detect effects. So I think in a very early assessment I did on this, there's a pretty small proportion, like maybe 6% of the data gets bumped out if I put some sort of threshold on there's been a change to the forest structure after the point count was conducted. But I do need to do that again once these the full 36,000 sites are into the data set. Next steps are to strategically sample data to improve the models and fill in gaps. To test the use of the density map, is that a viable tool? Should it be based on total bird? Is there benefit in having individual species maps as well? And Kari alluded to that as well, especially when you're talking species at risk. And then how do we use this information to improve the matrix? Where do the assumptions hold? Where don't we? And can we develop a set of data-based rules to rank stands based on those VRI attributes instead of using assumptions that are based on the literature as they're done now? And looking even further forward, and I swear I did not coordinate this with Aaron at all, but I agree that there should be, it's one thing to talk about what are we going to do to birds in this summer, in this stand, but it's another thing to talk about long-term habitat consequences. And so can we create predictions, essentially? Can we predict the future of what the bird populations are going to look like, given different planning scenarios, given different planning practices, individual practices, given different BMPs? What does the future landscape look like under those conditions? And how many birds are we going to see on those future landscapes 10, 20, 50, 100 years in the future? And so that's where I think things need to be going. I want to thank all of the funding partners that have made BAM possible and this work. And that is